that gets called. So if this gets called, this processes some things and sets the shit, I don't know. I was gonna say this sets the this makes a collision happen and changes some position and velocity variables, but that's not true. Is it? I don't think we do that in... That's the reason we don't do that in the whatchamacallit class. Well, in the collision detection call. Or in the collide with call. The collision result class. Because collision handler. Yeah, so if you go to collide with, it's very simple for a normal physics entity. You don't get anything. And even if you go to moving entity, collide with is more complicated now. Actually. But I think we don't write to the actual variables. We save them in a result vector that gets applied only on the update. Right? Oh no. No, look at this. Velocity y equals 0. So we could actually be overwriting it, which sucks. This doesn't seem to be happening. Yeah, this part is kind of a mess. Yeah, it looks like all this other stuff is happening. But they only get written to the collision result deltas. Yeah, and that will never get resolved because they're taken out once we see this removed B. So, and I know that this guy isn't getting called, this part isn't being hit because the velocities don't get set to 0. Because the size still shrinks. So it's definitely this stuff here. Right? Okay. Okay. Gotta work this out. Okay, I need to eat sugar because the solutions aren't coming. And I am getting sleepy. It wouldn't be an honest cast if I didn't get sleepy and drink water as an excuse for not writing the solution immediately. So I'm eating some red and green popcorn. I believe this is a Hawaii thing. Looks like Christmas inside. But I don't know. It's been a while since I've eaten it, but the popcorn looks so the coloring is so sparse compared to how I remember it. I used to remember this being like something that's just gooped in green junk, and it was super shiny all the time, and you couldn't really see the white parts. Maybe they realized that was terrible for you and made it slightly less terrible. Okay. So right here is where I'm looking. It shouldn't matter what value this is, as long as it moves in the right direction. So let me think. You know what? I got it. Yeah. Okay, so check this out. So the size is this. This is the size, right? This guy going down. This is size. Do I have it? No, I don't have it. Damn it. I was gonna say we move this amount forward. Say we move that much down. And we don't adjust size. Yeah. Then the object will be like this, right? It'll be this bottom and this top. Now we want this part to stay the same, so we move, yeah, we want pretty much this inner thing, and we have this thing instead. So to get from that to that, we cannot just minus this much size. This is a differential equation, isn't it? I hate these. And that means a naive implementation will be pretty expensive. Okay. Do you see the problem? This isn't the best drawing, but maybe you can follow. So the original, I'll draw it this way. Original in green. Okay. When you move upwards, we're going to move upwards now, just for fun. When you move upwards by this amount, then the resultant, after you move, you will be in this position. Oops. Something like that, right? Yeah, and we want this inner, what we want for our new guy is this inner thing. We want the Y part to stay the same. The Y top to stay the same. We want this white square as our result. But what's happening is because our position is represented by the middle. Yeah, so the middle of the green one is, we'll say it's right here. And the middle of the red one is just this amount higher, so it'll be right here. Yeah. So if we move up and then we shrink the size, we're shrinking the size equally top and bottom around this red dot. So what that will do is not end up being this, it won't being this, end up being this nice pretty white thing. And the reason for that is, as you can see, the bottom of the white thing already touches the bottom of the red thing. So once you shrink the size, well, you will get something like this. It'll be in the middle of these two and a little bit above that. This is the object you end up creating. The width of these is clearly irrelevant, so just keep in mind I'm only paying attention to the Y axis. Yeah. So this thing still has its center at the red dot, because we can't change that by modifying size ever. So that's essentially the problem. We move up too much. If we do a stupid way, this could be a differential equation where we try to figure out this difference and half of that and half of that and whatever, and eventually you get to pretty close. If you go to infinity, you get all the way there. But that's not probably the way you want to do it. So a simple solution is look at our green original block, look at the white block. What's the position of the white block? Well, it's exactly between... Is it exactly between these two? I believe it's exactly between these two. That's just my intuition. I haven't computed anything. Ooh, that's tricky, isn't it? That's a lot trickier than I thought it would be. It's probably like a super common problem. Because it would happen to spheres too. But spheres, you usually don't care about edges perfectly touching. Yeah, I mean, this, when you draw an example like this, it's small, but remember, these get compounded over many updates. So that's ends up being pretty big. Yeah. Yep. So, while I'm eating my popcorn, let's think about how we can prove up the white dots in the middle. Well, here's a good way. When you shrink the size, yeah. So in this, with this red block, if I just chopped off this amount to get the white block, that's the amount of size I will have to remove. And the position that I have to lose is exactly half of that, because the position loss goes around both sides evenly. I hope that makes sense, but that's good enough for me. Let's take a popcorn break from the popcorn break and write that in really quickly. So the size part remains the same. The difference is that I want to scale. Yeah, I will need one more vector, unfortunately. No. I can do it like this. Yeah, so this is to figure out how much to move. Then after we've added the stuff, we've changed the size. Yeah, then we do this. And we can also do filter vec scale. And we do NDP 0.5 NDP. Yeah, so this essentially changes the move from the whole thing to just half. Yeah, does that make sense? I think it makes sense. We should make the comment scale by half because we have to compensate for